Hello, everyone. My name is Vahid Ranjbar. Uh, I'm going to talk today about what is education in the age of artificial intelligence. I think basically we see that as AI has advanced rapidly, many people are asking themselves whether education's traditional and practical aims, such as communication, information retention, workplace skills, are being reshaped or even replaced by these new artificial intelligent tools. Uh, and then it appears, I think, to draw into question the very basic notion of the purpose of education. I think this moment invites a deeper question about what education is beyond, I think, what we've been, trained or developed to think that education is about utility. And that maybe education is fundamentally a little bit more than that, or should be, and should be focused on the cultivation, getting our capacity to reflect divine qualities. Uh, in the past, there was even, lots of anxieties about different technological changes. More recently, in the 70s or so, you had the introduction of calculators. People were worried, oh, people will forget how to manage math. If you go deeper into the past, even the introduction of writing, for example, was anxiety. If you read the Plato's commentaries on what Socrates uh, mentions this, that, well, the worry was that this would prevent people's ability to memorize because they could always look things up. Uh, and so you see that, this advent of technology disrupting education is not necessarily something new, but what we're seeing now, I think, is fundamentally more profound. And I think it really invites us to kind of think about these issues. And I focus us from this utilitarian view of education as, oh, well, we're trying to train people so that they can do X, Y, and Z, which was, I think, motivated in the past by kind of the industrial revolution and the desire to generate workers who could perform certain functions to this, I think, a spiritual point of view where we see that education is really about being human-centric in developing human capacities to know reflect the divine qualities, to know the universe, to reflect the realities around us. Before we go in, I think it's worth also spending a little bit of time looking at the early history of artificial intelligence, since I think in my discussion, a lot of this is going to inform some of the ideas that I see that we can glean from artificial intelligence in how we can think about education in a different way. So if you go back to basically the early 1940s, this is really the time when we see the genesis of neural inspired machine learning methods. They began really as an attempt to model biological cognition. And so you have the earliest neural network models in 1943 with McCulloch and Pitts. Then later in 1949, Hebb theorized that when neurons that fire together should wire together. This is kind of a famous axiom of how these networks of neurons should learn. Then in 1951, you had really realization of actual physical type of neural network made up of switches and analog connections. They built this machine called the stochastic neural analog reinforcement calculator, or SNARC for short. Uh, and finally, in 1957, really, I think the seminal discovery or creation of the perceptron by Rosenblatt. And so this is now worth maybe describing a little bit in detail how it works, since it motivates the rest of our discussion here. So a perceptron, a classical perceptron, basically is simply a method where you sum over a series of inputs uh, by multiplying each of the inputs by given user-defined weights, as you can see in the image here. And then all these weights are then added. A bias is again, another user-defined bias is added to that. And then all of that being summed together is then compared to some step function uh, and some threshold, basically. And then you decide, is it going to be true or false, on or off? And that's the basic unit of perceptron. And what Rosenblatt discovered was that by using a series of these perceptrons and connecting them to uh, some photo sensitive instruments, that he could actually get it to recognize different objects. So maybe different writing, like script A, B, or different geometrical shapes. And uh, this, for him, really, when he wrote about this in the news, he kind of celebrated this as being kind of the birth of artificial intelligence, and kind of heralded a lot of great things, which in retrospect may not have been too off the base, but were quite a bit premature for the time. Uh, Now, one of the problems of these type of perceptrons that was later discovered was that they were really only able to perform a limited number of equivalent logical types of functions. So, with a perceptron and training it appropriately, you can realize logical functions such as a logical and or a logical or. However, handling an XOR type of logical statement, it was not able to do. And this is traceable back to the fact that if you examine those functions there, they're linear functions, and they don't really have room or ability to handle higher order nonlinear types of shapes. And so there's this famous book that was written in 1969 called Perceptron. And on the cover, as you can see here, there were two different shapes which looked very similar to each other, but were distinct. And that the perceptron was unable to distinguish between these two. And this was kind of a critique of the perceptron that was written. And so because it didn't have this ability to handle these high order types of logic. Uh, but it was also realized that this could be solved if instead of just one layer of these perceptrons, you start adding another layer on top of that, and another one. Now all of a sudden you had the ability to, by concatenating them, to get high order terms, and then you could actually distinguish these types of images. However, the problem was, how do you train such a deeper neural network? It wasn't understood how you would be able to do this. You could not follow the simple rules that were used to train the perceptron that Rosenblatt had come up with. And so you needed something else. And really, it's interesting that what they finally came up with was this thing called back propagation, was actually discovered, forgotten about, or ignored like multiple times. It's quite amazing. But it was finally in 1986 that Romhard, Hinton, and Williams developed this, what now became famously known as backpropagation, to train these multi-layered perceptrons. And one of the things that they realized in order to make this work was that they needed to replace that step function with a sigmoid function. And this was because the step function, if you know a little bit about calculus, you couldn't take the derivative there. The derivative at a step is not is undefined. And so you needed a sigmoid function that you could actually take a derivative of in order to now uh, take a derivative of the whole system and thus understand uh, when you're evaluating the output of the function, evaluating whether or not stepping in one direction in the weight is going to get you closer to matching the desired output or further away. And so um, so together with this sigmoid function, and I've already alluded to this use of the chain rule in calculus, which is just this old you know, rule that was basics. Anyone who's taken calculus knows this. You could now relate the errors in the output of a given neural network all the way back to those weights that I was showing you earlier and decide, oh, do I need to change that weight either a little bit up or a little bit down in order to get closer to the truth? And so using this method, you could very quickly now train these deeper networks, these layered networks, and to great effect. So Hinton actually and his group would go on and do a lot of other great things, which I'm going to talk about here in a minute. Uh, so it was also around this time, by the 80s, the late 80s, that you also started to, and even earlier, that you started actually see these type of networks being used commercially in an industry. So initially it was in signal processing that it had some use. And then later, even in the post office, they would use it to sort the mail, reading the addresses that were handwritten. Uh, but there were still limits to this. It kind of stagnated again for another decade or so until the mid 2000s. Again, Hinton and his group developed what are known as deep belief networks or DBNs. And in this way, he was able to demonstrate the power of deeper architecture. So now, not just a couple of layers deep, you have these really massively deep layers. And he was able to show that you could now use these systems not just to classify, but also to start to learn the very nature of the structure of the input data that you were receiving. Uh, and in doing this, he deployed these so-called restricted Boltzmann types of machines, which really allowed the system to understand the statistical distribution of their inputs and also what the outputs would be. Later developments in this vein would give rise to what we call generative modeling, including variational autoencoders and diffusion models, which we now are familiar with when you look at programs like DALL-E or these others that generate these beautiful images. Uh, so what these outputs did not just simply produce from a given input some output, but they actually learned the structure of the environment from which the inputs would arise. And I'm going to talk more about this, but I think this is actually a very profound idea. Uh, I looking at this have come away with basically three principles of learning. I think we can see in studying the history of the development of artificial intelligence. The first is that you got to learn from errors, and so this is manifested in gradient descent and back propagation. In machine learning, the system compares its output to a desired goal. And then it measures the error and back propagates it. Uh, Another idea that was developed, I did not mention, but was important in training these deep neural networks was the idea of skipped connections. So one of the problems that they found in training these deep neural networks was that those gradients, those that they as they would back propagate could get vanishingly smaller and smaller and smaller, so it was indistinguishable from noise. So one of the ways around this was that they would actually have skipped connections. So they would have connect one layer uh, at the top would be connected maybe all the way to the bottom or intermediate layers, so it could jump jump layers. And so in this way, these shortcuts would alleviate this problem of vanishing gradients. Uh, and finally, what the third principle I think of learning relates to this idea of probabilistic learning, or the need for a system not only to optimize its outputs, but also to develop an increasingly accurate model of the environment in which it operates. In machine learning, this often entailed developing a probability distribution of the inputs, identifying the variables that matter the most, how they vary, and determining, excuse me, what their what structure underlies the observed data. Such a system does not simply react, it learns to understand the world to which it must respond by internalizing the semantic structure of the data provided. So now applying these three principles to human education. So this is kind of my first shot of this. This is obviously a work in progress and my initial thoughts on this subject. So the first one I think is that this idea of backpropagation or learning from errors is the most straightforward. We see this already in education with testing and testing students and getting them to learn things. But I think what it points to, though, beyond that, is a kind of more recursive process of learning. That this process of testing should not just be this high stakes one-off approach, which we often see, which is used to sort smart students from less so smart students in a particular uh, vein. But instead, it should be occurring repeatedly over time, and its focus should be on training that student and getting it so that that they master the material, and that testing is integral to that process. And also, I think does away also with this idea that's often common in education where you give a huge amount of weight to the initial performance of students. Uh, and so you sort them out very early on instead of, well, maybe this particular network may initially not be productive, but later on could be fruitful. And you just give it the time is necessary to train it. Uh, a second idea is the skip connection idea. I think in education, uh, could be realized in the deliberate revisiting of fundamental ideas or cross-correlating concepts late in the learning process, and perhaps even inviting an interdisciplinary approach to study. But I think there's more that can be thought of in this vein. Finally, the one that to me is the most interesting one is that in this instance, the question becomes now for the third principle is how best to represent the structure and contextualize the information that you need to be learned. So you have this body of data. So now the important question is not just memorizing it, but understanding the structure of that data and understanding it, how best to organize it in a way that it can be represented and learned. Uh, I think actually this last idea connects to a very profound notion that man is a supreme talisman. Lack of a proper education hath, however, deprived him of that which he doth inherently possess. Regard man as a mine rich in gem of inestimable value. Education can alone cause it to reveal its treasure and enable mankind to benefit therefrom. If you dig a little bit into this idea of talisman, you see that it goes beyond this idea of a magical object that brings good luck to its bearer in its surface meaning, and goes back to the mid 17th century in Arabic term. It comes from this idea of talisman, which is related to the Greek term. And really, I think when you get into Islamic and particularly Shiite understanding of this word, it represents a very rich cosmology where the talisman is seen as a representation of a higher object. where one can attain some gnosis of it. So, in this context, humans as being the supreme talisman might be understood as a reiteration of the idea of man made in God's image, such that within them the absolute is modeled or imagined. So I think this idea of talisman, in my opinion, really is representing this concept of the human being this imaging God or reflecting uh, God. This itself, I think, connects now back to information science, uh, this idea of semantic information. Here, this concept of something that models or mirrors something else can be understood through the lens of information theory and thermodynamics. Uh, and both of these theories meet on the plane, really, of symmetry. Uh, this word information actually has a lot packed into it, and there are different types of information, as the father of information theory, Shannon, made clear. There's syntactic information, which is kind of these physical measurable bits, and that's what Shannon claims he was working mostly on. But then he also mentions there's this semantic information, where this information actually has meaning. It relates. It's a relationship between these two variables. There's this other idea known as fissure information, which overlaps with Shannon's mutual information, which is also these both are types of semantic information. And the basic idea is that you can have one variable that is related to another variable. For example, one example I use is that you look at your watch. The arms of your watch have semantic information relative to the sun-Earth system, because it tells you when the sun is going to rise and when the sun sets. So there's a semantic information between the arms of the hands of your watch and that system. Uh, and I think you can cast the progress of human science itself as a type of progression of different types of semantic information. So you can look at human scientific process as generating better and better mathematical models of the physical world. For example, the Copernican revolution, which moved us from an Earth-centered model to one which was centered around the sun for the solar system. This was useful because it really greatly reduced the amount of the variables that you needed to represent the universe. It condensed the semantic information into a very precise and reduced manner. So there are far more few variables you needed to contend with. It's not necessarily that Earth-centered was wrong in a sense. And in physics, you can choose any coordinate system you like. It's that by moving to this particular coordinate system, all of a sudden things became much easier to work with and easier for us to make predictions about how things are going to behave in the universe. And I think this generally describes what we do in science, is that we are developing these models which represents reality and beat predictions, make predictions that beat chance. And this is the power of them. And in fact, this may be, some people have argued that this actually is really part of what drives evolution itself, that evolution is a process of generating this Fisher's information, as talked about before, that this ability to make predictions that beat chance is really at the heart of evolution. And it was why many complex systems greatly reward any part of it that is able to generate a prediction that beats chance. So you can go become a billionaire if you're able to predict the financial markets, for example. Uh, so finally, moving back to education as mirroring the divine. Uh, and he, in this manner, just talks about his disciples as letters of the living. Thus, the body of believers represent the letters that join together and form this divine word or the manifestation of God. Thus, the joining to the manifestation of God is embodied in the ultimate command to know God and to love Him as the ultimate purpose of this existence, and could be seen as a culmination of this natural evolutionary process to know God or know the universe and to love it and to uh, the process of education and its operation on an individual can now be viewed as exposing the inherent information generating power of the human mind or spirit. And thus, education helps move the soul to a state where it is more faithfully reflects the realities of the universe and ultimately God. So I argue that this itself is a manifestation of that third principle of AI learning that I discussed earlier, is being able to model the environment that you're in. Thank you.